The purpose of this video tutorial is to provide a simple example on how to apply reactions that are established from a global finite element solution in Adapt Builder and how we can apply those reactions to a single level. In this case, we're going to use a mat slab as our example. And so we'll go ahead and get started. We're going to launch Adapt Builder. And we want to make sure we have the proper selections made here in the splash screen. In order to analyze the global model, we have to have Adapt Edge enabled. And because we're going to be looking at transferring reactions to a foundation, we're going to select Mat. The same could be true, for example, for a transfer slab that's elevated, we would use Floor Pro. We'll go ahead and use this set of settings, and we'll now navigate to the model. Okay, in this model, just to familiarize ourselves with it, we have basically three planes. We have bottom plane where the mat will reside, we have current plane, and top plane. Now, right now we're working in what we call single level mode. If we hover over that icon, we can get a description of what that mode is. You can see the active plane is the bottom plane. That means anything we model will be established at this plane that's active. If I navigate up one plane in single level mode, this is the slab level. This is the current plane. And then the top plane is void of any components. So we're really working at the current plane and the bottom plane. This is essentially a concrete box. Okay. And this could represent something larger. You could have multiple levels other than just two-level multi-story structures. So if we go to multi-level mode, and I'm going to turn this into a 3D view here, you can see we have a slab and four walls. Okay, now there's nothing yet modeled at the base. We're going to add a mat slab at the base here in a moment, but we just want to make sure we understand the difference between global or multi-level mode and single level mode. In terms of the loading on this particular structure, if we go over to loading, load cases, we have general loads defined. We have a dead load, live load, okay, and then we also have EQX. And if we go to the loading visibility options, I'm going to just show all of our loads. Okay, currently there's only one load that's actually produced, and this load, if we look at this, this is a patch load. It's EQX. Okay, EQX is active in the plane of this slab. All right, and this is the load here. You can see the vertical magnitude is 0, but the lateral magnitude is actually 100 pounds per square foot in the plane of the slab. So we're going to leave that as is. We're also going to go now, and let's go back to single level mode. I'm going to navigate down to the base of the structure, and I want to model something at the base. So I'm working in single level bottom plane. We're going to go over here to model, and I'm just going to model a slab, and this will be a mat slab. It could also be footings, continuous footings, spread footings. Whatever represents your foundation could be modeled here in this level. So we'll do a mat. This mat we're going to say is 18 inches thick. Okay, and now just quickly, if I come back to the 3D view and go back to global mode, we can see the entire structure in place. I'll go back to single level. In order to stabilize the structure and obtain reactions, I need to add some sort of supporting mechanism for the model. So that will be in the form of an area spring. I'm going to just model an area spring. Okay, we'll exit. I'll double click on the spring and I'll define the spring properties. Now, this will be a compression only spring in this example. And you'll notice that the subgrade modulus for the lateral X and lateral Y directions are both 0. If we run the model under this condition, there will be an instability in the model. So we need to assign some value for Kx, especially. We'll just use 1 E plus 4. This will just give us some stabilization in both X and Y directions. I'm also going to add loads to this level itself. So we're going to take this slab region. This is the mat slab. Remember, at the bottom plane. I'll go to loading, and we're going to add some dead load. We'll say the dead load is 0 we'll say it's just 20 PSF. The patch load, uniform live load, I'm going to say is 100 PSF. And I'm also going to add some line loads. I'll add some dead load for line loads. So we can go ahead and add a line load. In one case, I mapped the load using the wizard. In this case, I'm just adding a line, point, or polygon. So we're going to add some line load along this path and maybe this path. And we'll say that this is going to be a vertical dead load. And I'm going to say this is 5 kips per foot here. Over here, we're going to say that the load is 10 kips per foot. Okay, we could also add, point moments, whatever types of loads we want to add directly to the mat. Those are also in place. Now we are going to generate reactions in overturning moments and also axial load from the axial load that's applied at the top slab. We're going to show you how you can run this in multi-level mode and then reapply those reactions to the structure. So once we've modeled our system, we'll go back to multi-level mode. We're going to save the file, and now I'm going to mesh the structure. I'll go to Analysis, Mesh the structure. If I'm in multi-level mode and I mesh, it's going to mesh all slabs in the model, like so. I don't want to see those elements. Things get a little bit messy visually, so I'll go back to visibility and just go back to my default display and turn everything off, other than just the components. The default display items are actually set inside of View Settings here. We can select and then save as default. Okay, once I've meshed it, now I can analyze. So we'll go to Analysis, execute the analysis, and you can see there are some dead loads that are not defined to a load combination. If I select no and I go back and review the combinations, we have EQX only, 1 times EQX, and self-weight only, 1 times self-weight. We could add another combination here. I'll just call this all loads. And I'll set it to no code check, just as an example of, okay, and we'll say this is 1 times self-weight, 1 times dead, 1 times live, and 1 times EQX. We'll say okay. And now when I go to analyze the structure, that warning won't appear because now I'm actually using those load cases inside of a combination that is being evaluated. So this gives us the ability to filter out the combinations we might want to evaluate. Now there's 2 options here that are very important, and we'll describe each of these options. The substitute option here means that because we have a compression spring at the base of the structure, we can choose to substitute those springs with fixed supports. This just allows the program to solve this model faster because now we can use superposition in terms of building out the solutions for the combinations. Otherwise, we can use compression springs. If we use compression springs here, the second option, this is a direct solution, meaning I'm modeling a global structure with springs at the base. Technically, I don't need to rerun the mat foundation because I'm already considering the soil condition at the base. If we use substitution, then we want to rerun the mat foundation in single level mode so that we can reapply reactions assuming a fixed base solution. So we're going to use the first option, the substitution option in this case. We're going to use this option here. We'll go ahead and select that. We're going to come back to this over here on the right in just a moment. So I'll analyze the structure and we get a solution. Now, how do I know that the base is fixed? Well, if I navigate back in single level mode to the bottom plane and I turn on, for example, in the result browser for, let's say, all loads, if I go to the slab graphical results option under analysis, I'll look at deformation in the Z. This deformation for the Z direction, let's go here to the result viewer. This deformation should be essentially solid. In other words, there's 0 deformation at the base of the structure. Okay, so this gives us a solution for deflection under a fixed base. If I go up one level, you can see this is the deflection at the upper level, assuming a fixed base. Looking at the model globally, if we go and, for example, this load case that we're going to review will be, let's just use self-weight only. Looking at the self-weight, obviously this upper slab deforms, the walls deform, but the lower slab is fixed. It's not, there's no deformation there. So this is what we would expect when we substitute at the bottom of the slab. Now that I have reactions in the walls, if I look again at self-weight only, for example, and I go over to analysis and I'll collapse this and expand out the walls. If we look at the actions, you know, for wall forces, let me turn off the slab contours. So we can see here the axial forces. These are for self-weight only. We could change the combination and see axial forces, for example, for all loads. This is a global solution. So these are the reactions that would be applied to the mat foundation when we run this in single level with reactions. But these are based on a global solution. We could also check things if we look at EQX only. If I go back to analysis for the walls, I might want to look at the shear along the walls. Here we have the strong direction, so we have the shear buildup in these two walls, and also the moment about S. This is the strong axis moment in the walls. It is these values, again, that are applied as reactions when we apply the reactions to single level. So we have a global solution in place. All of the results we're looking at are from the global run. Now that I'm in single level, I'm going to actually rerun this slab with springs with the reactions. So we'll go back to execute analysis. Notice I'm in single level. I have no chance here to actually tell the program which to run because this is enabled is disabled once we go into single level. It will by default run the solution with the compression springs in single level mat mode. So, but we also now have the availability of the reactions to be reapplied. So the lateral reactions, this is this first option is for lateral reactions from a building load case. In our case, we use general loads. So if I select this, nothing will happen because there are no building loads defined in this model. There's just general loads. If I use load takedown, now we have the availability of reapplying the reactions for dead load, live load, self-weight, and EQX. Notice these are only the vertical reactions. If I want to include moments and shears at the mat, I need to use include gravity reactions. This changes the reactions to all. So once I do that, we're going to reapply the reactions. Notice this solves in single level mode, and we do have some instability. If we go to the result viewer, let's check, for example, EQX only. And we're going to go over here and look at the deformation in the Z direction. And we can see we have, because this is a compression only spring, we basically have uplift on this tail end of the slab. That's why you get the stability warning, because of the uplift. One way to see this would be to go, once I select the deflection view, I can go to visibility, render model, and using this selection here, you can see renderings or warpings of the model. So this is completely going off the page because the value is so high. If we go back and we look at the deflection, for example, for self-weight, and I look at the vertical deflection here, you can see the range of vertical deflection. This is much more reasonable compared to the EQX deflection. And then lastly, if we look at the all loads, this includes gravity and lateral, you can see again the range is reasonable. We have some deflection here that's still in compression. We get more compression on this side because on the left side we're relieved there a little bit due to the overturning from the seismic. So this is kind of the toe side where we get more vertical displacement downward. Now if I rerun the single level without the EQX only load case, then we're not going to get the stability warning. We can still reapply reactions, but we don't have this isolated EQX load combination that triggers that stability warning. This will run and just give us a solution that says, hey, this solution is reasonable. There's no excessive displacement in this particular run because we excluded that one load combination. Okay, and this allows us to obtain that solution once we rerun that. The last thing we're going to do in this example, we're going to go back and let's go over to analysis and just turn off the contour. Okay, in order to turn off a contour, if I turn that back on, I can always just turn it off in the checkbox or use this blue arrow to clear everything. I'm going to go back to global mode, and rather than running the model with substitution, I'm going to just run it directly with compression springs. Notice that the reactions are not reapplied in a global setting ever, so these are disabled at this point, and we'll rerun this using the springs at the base. Again, we get a stability warning because we have excessive overturning and displacement in the mat foundation. If I rerun this again without the isolated EQX, we will get a stable solution for the model. And again, once I rerun that, I don't have to go back to single level and run the model again. I can just look at results. I can look at displacements. This is for all loads. I could look at soil pressures, for example, since we have a compression-only spring. We can still look at wall reactions or wall forces. We ran it globally with springs now, so they might change slightly based on the solution where we substituted the springs. But we can go to wall actions here and again look at axial force, shears, moments, and so on. Okay, so this is the global solution with springs. We'll call it the direct solution. The global solution with substitution, which then requires a rerun in single level mode with reactions, we would call it, let's say, an indirect solution. If you have any questions about this video or about the process in AdaptBuilder, please contact support@adaptsoft.com. Thank you.